for that. I think before I answer that question, I think let me try and elaborate a bit on the ecosystem and how it has changed. At least a few years ago, it used to be just on-prem, or it used to be a cloud, and at some point it became cloud. Now, the era that we are living in, there is while we have a lot of applications that are being built for cloud, there are also a lot of applications that work on mobile devices, work in your private data centers, and also work on devices on edge. So let me take an example of one of any application or any service that offers food delivery or grocery delivery. We think about it as a consumer, as a mobile application, but in fact it is not. They have a large cloud application or SaaS application, which is used for inventory management, which is used for pricing, retail distribution management, and things like that. In addition to that, they have mobile applications for consumers, for them to go and order, and mobile applications for delivery personnel to track their delivery, receive their orders, track the delivery. And there are pickers within their inventory shop. They have handheld devices, which may or may not be mobile devices. They could be some specific kind of devices which also need to be interconnected. So we live in a world which is very lot more complex than what it used to be, and all of it is to achieve faster time to market. And this has made our ecosystem kind of not just cloud, but on-premise, hybrid, mobile devices, and devices on edge. With that, obviously, the one thing that comes to our mind is the complexity of application delivery and packaging. But there are a whole lot of other challenges that come in. One is unclear delivery requirements, as in how do I, if let's say Big Basket or Amazon is having a sale, how do I make sure that the sale information is available in all the applications in the ecosystem that I mentioned on the same day? So how do I deliver those applications? I take care of the errors and issues that happen in the application delivery. And switching over a bit, let's say if you figure that out, where will you find developers? Where will you find the people with that technical background to implement that for you? And something that it is even more non-intuitive is the compliance and security aspect, because most of the engineers can figure out the development aspects of it. They can learn languages, they can learn mobile technologies, but they don't know what is the compliance level that it needs to operate in. For example, if you are taking someone's credit card information, or if you are having someone's home address, how do you safeguard it? What are the regulatory authorities that are there to ensure that information that you have collected does not get leaked? And if what are the measures that you have put in place to avoid that information leakage? So as I speak about it, as I think about it, I hope you get a picture of how complex the ecosystem has become. I think, first of all, the first change, which is not intuitive, is a cultural, is a developer's job. Security is a security and compliance or GRC team's job. And managing the application is an operations team job. This is the biggest barrier for us, for any organization to be successful. Because an application developer cannot build an application which is secure if he or she doesn't think security and governance is their job. Similarly, he or she cannot build an application which will run in a reliable manner 24/7, 365 days a year if they don't know the facets of operations. So these things are no more disconnected. Gone are those days. And I think accepting the fact that these are not different domains, different responsibilities, anyone who is involved, they should be thinking about it holistically. The same is holds good for security also. And this is, in the previous like 5 to 10 years ago, CISOs used to be check gates for every application launch. These days, if you look at any startup who have started, who had an idea and who brought it to production, they didn't have a CISO to stop them. In fact, the developers were thinking like security personnel. And even if there was a CISO, they were working hand in hand with the application developer to say, if you are building it, these are some measures that you have to do from day one to make it secure. And it could be as simple as, if you are using AWS S3 service for storing your data, it should be encrypted, zero, like no arguments, right? So they give a prescriptive instructions in the beginning of the product development lifecycle. They do not come in as a blocker at the end of development and blocking the release. So I think these silos needs to be broken, and that's where adoption of DevOps practices and DevSecOps practices comes in. So to summarize, culture is the big barrier, and we have to rewire our culture to break these silos, and only then you can adopt methodologies like DevOps and DevSecOps. Second aspect is, let's say you are now in that mindset of collaborative development, collaborative security, collaborative operations, and take a DevOps, DevSecOps approach. Then the next is to pick a tool and methodologies which will enable you to do it. And that's where products like Chef come in, where we help bring all these teams, break the silos, speak a common language. And the common language that we bring to table is code. And we help application developers package their application through code. So they can define what goes into their application, what all software they use within application, what is the dependency of those softwares in piece of code. And similarly, operations can codify their infrastructure in code. So if they have to use certain number of CPUs, certain amount of memory, they can codify that. And then security people, they security and compliance, if they have to adhere to SOC 2, if they have to adhere to PCI DSS, they can codify that. So the moment all these three people speak the same language, that is code, we help provide policy as code as a binding methodology with which they can, all of them can set up processes to execute them in a collaborative manner. And the third bit is, so this could be like, there are a whole lot of, it's a large paradigm, but it enables you to not trust anyone without who, if they don't authenticate themselves. By default, you do not trust an entity, as compared to the previous or the common knowledge, where you trust and verify. Here you don't really trust anyone, any entity. So adopting zero trust methodologies and ensuring that you have, that will give you a very, very clear mandate on what level of security you will have on your infrastructure. And last but not least is the skill. So you need, for you to do it is easier said than done. You will have to hire people of right kind, build the right competence, and make sure that you have the people of right skill to match with the cultural gaps that you have tried to fix. Like I mentioned previously, I think adoption of DevOps and DevSecOps methodology is going to give you the tools to accelerate your development and be secure. Just to give you some insight, we did a survey to IT and security practitioners last year, and one of the top factor for them to adopt DevSecOps practices was they had the business need to be fast and make frequent delivery of applications. To reword it, they could not live with a scenario where they do application update once a year. We want it to be locked down. We want to do all the testing before we release, so they can wait for a year. Whereas these organizations have the mandate to make frequent releases. They can't wait because their competitors are eating into their share. So they have to keep building features, but they have to be secure. So there is a very, very clear business need for fast and frequent software updates. And 56% of the people who have adopted DevSecOps have done it because of this reason. And the second reason is the looming cybersecurity threats that are very, very evident these days. So that is about 57% of people have adopted this because they know it is not if they get attacked, it is about when they get attacked. So these are the top two reasons for adopting DevSecOps. And while it provides a fast-paced approach to solve this, you have challenges that kind of I referenced in the previous question, which is around choosing the tool and training your team and building integrations between the tools you have. So one of the another challenge that we see in organizations which have mindset to do it, but are having difficulty is integrating a whole lot of tools, because each organization has their business needs, and this space is evolving so fast. They need to be able to integrate, and that's where choosing a tool which can speak language of code, which has infrastructure as code, compliance as code, security as code, CI/CD as code, GitOps GitOps workflow as code. So if you choose as a code approach to your solution, then you have very relatively easier to integrate with other tools. And switching gears a bit in terms of the challenges, when we talk about legacy versus modern, there is a big gap of choice of technology. Organizations want to move to cloud, organizations want to adopt latest technologies, but their majority of their business is coming from on-prem or legacy applications. So how do you modernize applications is a third challenge. In fact, in my career, I have worked in almost all organizations where I have worked in. We always had a legacy application. And there was a dream by someone in the organization that we have to modernize. And they create two different teams, one new and another legacy, and that's the end of it. And nothing moves from legacy to modern. Now, I think recognizing that this is these things can't be siloed. These things have to be very cohesive, and having a very dedicated focus on modernizing application while you are adopting new methodology is also a challenge that a large amount of organizations don't recognize and fail in the process of adopting DevOps, DevSecOps. And last but not least, we have, again, going back to one of the surveys that we did, which I can reference to, only 36% of them, 36% said that they are able to do a balance between adding new features versus bringing old system to modernizing old system. Right. So if the more you have more teams having better balance, more chance of being successful there. This is interesting because this is something we have worked with some of our customers who have such diverse ecosystem. And to be honest, when we started this journey about 5-6 years ago, we also underestimated the complexity that is involved. And let me start with some of the basic or some of the things that are slightly intuitive, more intuitive than others. First is packaging application. So let me, going back to the first example that I took about order delivery or food delivery platform or grocery delivery platform. We have a website, we have a mobile app, multiple mobile apps, and we have a point of system devices. Right. So each of them, let's say, let's take an example of if we are running a offer or some discounting, all of it, all these systems needs to be updated on this with the same information on the same day. If they don't do it, the picker will not know that there is an offer, and he or she might not send the free thing that needs to be sent out. So that leads to low customer satisfaction, because it was shown in their mobile app, it was shown on their website, but customer didn't get it. So they are going to be unhappy. So that's where packaging of application and distribution of application becomes the first challenge. And taking this example, I need to package application for website, I need to package application for iOS, Android, and also I have to package application for POS devices. And mind it, these are different applications. So this is one. Second, and this is second is the latency or the unreliability in distribution itself. So some of them might be within your network, so you know that they are available. Some of them might be over the air, over internet. And let's take an example of a runner who has been going around on a day-to-day basis and connected only through mobile connectivity. So you don't know how good the connectivity is. You don't know if his or her mobile phone is going to be switched off because of lack of battery. So there is no reliability about application upgrades and application, the software update, update delivery and updates. And third, let me, sorry. So in this case, network reliability, network availability is the second challenge. And third is your security. So, or third is application reliability itself, meaning if an application is running, how do you monitor its health? How do you make sure it is running healthily across the ecosystem? And how do you take remediation actions if they are not running as expected? So taking an example of a fuel pump, where historically we knew fuel pump had an analog meter, and all it had was how many liters or something like that. These days it has price component, and you can key in some money and it will automatically calculate how many liters or what quantity of fuel you are supposed to get. So if that system goes down, what is the impact of it? Right? How do you update it immediately without having to send someone to that particular fuel station? So application reliability is another challenge. And last but definitely not least is security. How do you ensure that your application doesn't get compromised? Like a very simple example, how do you ensure that someone doesn't install an application mimicking your business application? Think of a scenario where someone has Amazon equivalent or Big Basket equivalent on your mobile device, and if they start harvesting data from mobile device, they will launch a complaint saying that Big Basket or whichever company has compromised my data, but in fact it is not them. So how do you ensure the security aspects of these devices or the applications? And that is where some of our products or product like ours come in, where in Chef we offer an end-to-end solution called Edge management, where we help them first to package application, and application can be packaged as containers, application can be packaged as binary, a small executable, lightweight executable for any operating system, and even for Intel devices, ARM devices, different devices. And it can be packaged even for lightweight POS devices where it has low CPU footprint, low memory footprint. and it also can be deployed in a secure manner in multiple distribution topologies, which helps in addressing the network reliability issue. And also it has ability to monitor the health and kill the application, restart the application, or reinstall the application. So some level of application lifecycle management is also built into it, so that we can help address. And all of it is adopting as a code approach and well integrated into the DevSecOps ecosystem. So it is, if you hire any expert in DevOps DevSecOps, he or she can learn this very easily, because they fundamentally they know the concepts. The tool might vary, but the concepts of DevSecOps is what we have built everything from. It's in our DNA, and we have integrated as a code approach in everything that we have built. So this is an interesting one, especially when you phrase it around supply chain or service bomb context, because this typically each software that we use today is not working independently. It utilizes so many other software components. Just to take a very simple example, the application calculator, which I think there are math formulas to do it, but for it to render the UI, it uses some UI library. And for it to if you have some sound, or if you have some visual effect, for that it uses another library. So even very simple applications like that also use whole lot of other libraries. So if you look at complex applications, they have endless, I mean, it is not endless, but figuratively speaking, endless dependencies. So the first step in addressing these risks is to know what I have in my software. That is where software bomb comes in, bill of materials. So if you are bundling a piece of software into a device, if you are creating an application, you should know what all dependent software it has. That is step one. And second is to constantly monitor, am I using a piece of software which has known vulnerability? For example, we had a log4j vulnerability in specific version of Java. So if I know that my mobile application, for example, is using Java, that is the step one, and a Java version, let's say x.y.z, now I have means to actually look up and identify if my application is in fact vulnerable. So step one, know what you are using. Step two, have a mechanism to scan continuously and identify if you are using any vulnerability. And step three is to go and remediate them the moment you identify that you have some open vulnerability. Right? So this is one approach. So moving on to second, which is threat vector, right? So this is very defensive approach, where you are constantly looking for problems to come. And another case where you are under attack, right? Where someone has identified there is a vulnerability in your system or in the device or whatever that is, and they are attacking. And how do you defend an ongoing attack? I think for that also, understanding that in today's ecosystem, no one is safe, right? This might sound very paranoid, but I think adopting that paranoid mindset is required. Otherwise, it will be too late before you realize. So the moment you accept that I can be attacked, right? It is not about if, it is about when. Then there are tools that provide you ability to detect such attack. I don't think we can be 100% safe for every attack, but we have mechanisms to identify any attack. So building such system for threat detection is a very, very important thing, as much as it is important of identifying knowing what software I use. Right. So on one dimension, knowing what software we use, and second dimension, understanding your threat vector for your product and having threat detection mechanism and alerting mechanism on any threat that happens. Maybe it is false alarm, but still having ability to know. And third is compliance. I think compliance, people take it as a stamp, right? They want compliance because otherwise they won't be able to get past. I think we have to understand why those compliance were put in place, and these compliance are put to ensure to safeguard the data or safeguard the business objective, typically of the end user, not necessarily the business that is running. So having a continuous compliance posture is also equally important. That means you don't do your compliance audit every year, once a year, just because you want to get that stamp, but keep a continuous compliance posture, keep tracking of your compliance on a real-time or a near real-time basis, so that you know you are compliant, and if you are not, remediate that. So that will reduce your threat surface.